For this video, I'm going to use Stata to demonstrate how to conduct a linear regression analysis. And the data that we're going to use is the GRE activity data that's found in D2L. And I want to browse that data a little bit and show you that we have exam score, which is our dependent variable, and then GRE quantitative and GRE verbal, which will serve as our independent or predictor variables, at least for this example, not at the same time. So let's look at the relationship between these variables. If we go to statistics, summary, and descriptive statistics, we can go clear over here, and I know you can't see this, to pairwise correlations, and we can put in all our variables so that we can look at the correlation matrix. This will give us our significance. This will give us the number of observations. And so if we toggle to the results screen, we can see that the correlation between GRE quantitative and exam score is very high, 0.8547, and the correlation between GRE verbal and exam score is much less, 0.3137. This correlation is significant, this one is not. And of course, this is the number of individuals in the analysis. So we want to remember this correlation here because it's the correlation that will be used to conduct the linear regression when we regress exam score against GRE. So let's go back to statistics and then linear model and linear regression. And in this case, the dependent variable, we're going to put exam score. And for the independent variable, we're going to put GRE quantitative. And then we're going to go OK. And so this is our linear regression output. And you can see that it's quite a bit of information compressed into one area. So if we start with this part here, this is our analysis of variance summary table. And we see that this is sometimes, this is called the model sum of square, and it's in other programs it's called the regression sum of squares. Basically what this tells us is how much variability in exam scores is being explained by GRE quantitative scores. And then the residual is what's left over. That's the amount of variability that's not being explained. And so our degrees of freedom are based on, there's one predictor variable, GRE quantitative, and then we have 18 degrees of freedom for our residual, which is n minus 2. That's the number of variables in the analysis. And so this represents the mean square for these. So 1 divided into 2024.87 is 2024.87. 18 divided into 746.92 is 41.49. And then to get our F ratio, we divide 41.49 into 2024.87, and that gives us this value here, which we can see is highly significant. Our R-square value is simply this correlation between GRE quantitative and the exam score, 0.8547 squared. And so that's our R-square value. And what that tells us is that 73% of the variability in exam scores is being explained by GRE quantitative scores. And then we have our adjusted R-square. That's an R-square value that's adjusted for bias. And then we have our root mean square error. And the root mean square error is simply, it's the average deviations from the predicted values and the actual observed values. And so to make this a little bit easier to understand, hopefully, I created a graph in SPSS that shows this. So these dots here represent actual data points. This is the line of best fit, or the regression line, and it represents the equation that fits this data. And so the predicted values are on the line. The actual values are scattered about the line. So the difference between the actual values and the predicted values is error. So if we add all these errors up, we would get 746.925544. So those represent, these deviations represent that variability. Now, the root mean square error is the average of these deviations from the line. So, like a standard deviation, they give us a sense of, on average, how variable the actual data points are from the regression line, or the line of best fit. Then we can move to the equation, or the coefficient table, I should say. And the coefficient table provides the data that we need to create the regression equation. And so our coefficient for GRE quantitative is 0.969. The t-value is 6.99, and it's significant. So what this tells us is that GRE quantitative scores significantly predict a large proportion of the variability in exam scores. So GRE scores are explaining a significant amount of exam scores. And then our constant, this is a value that represents all the other variability not explained by GRE quantitative scores, is negative 74.99. And so these are the values that you would use to create your regression equation. And so if we were to create a regression equation, we could do it like this. We could say the predicted exam score is equal to negative, we can actually just round off, 75 plus 0.969 times x. So depending on the value of a GRE quantitative exam score, based on that value, we can use this equation to create a predicted exam score. So I hope this analysis or this demonstration's helped. Please let me know if you have questions.